Hey, everybody. Wow, that came out weird. Hey, everybody, this is Larry. This is day 21, 21st. Wait, is it? No, it's day 22, right? And there's a weekly premium prompt. So yeah, day 22 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prompt, which we will get as soon as it finished loading. I don't think I'm doing anything that funky, but it is having some technical difficulties. Got to close some tabs or something. All right. Today we have a easy prompt, which it's always good to kind of have a easy day, as running with no. For example, today I ran 6-7 miles, but easy, so that's good. What's not easy is, for some reason, the loading situation. Hope everyone's having a good day. I mean, at least today when we had dynamic programming, which people always kind of struggle with a little bit. But let's take a look. Today we have 476 number complement. The complement of an integer is an integer you get when you flip all the zeros to ones and one to zeros, okay? For example, okay, yeah, and its complement. Given an integer num, return its complement. Okay. There are a couple of ways you can think about it, right? I mean, it's fine. All the ways you can do it is reasonable. I think for a problem like this problem, right? I think as an upsolve is one thing I would do as an upsolve is to try to figure out like 3 ways of solving this, right? If like thinking about writing in a for loop, writing with an XOR, writing with maths. I think definitely you could. I don't know. If you think this is too easy, there are a couple of ways to solve it. I actually don't know how I want to solve it, just because there are so many ways to solve it. I think there is like a new thing that something like this. Is this a thing? I feel like that's a thing that's in Python. Okay, so it does. 5 is 3. Okay. Do we have negative numbers? Nope, and no 0. So this should be correct, right? So bit length. This is a new function that I don't know. I have to get used to using it a bit because I don't know. I just haven't been using it a lot. So then now you have this. So then and there are a couple of ways you can do from this, right? You can maybe have like 2 minus num, and I think this should be good, right? Unless I'm off by 1. Why is bit length for 5 is 3, so that's gonna be 8. 8 minus 5 is 3. Oh, is this minus 1? Yeah. Because you want all the ones. Okay, so that's like one way of solving it, for example, right? Maybe give a submit. Okay, that looks good, right? I'll just do one more way of solving it, just to kind of, based on this, right? Another way you can think about this is, I guess this is the same way, so it's not. I was going to do bit shift. So you do this, right? So that is going to be the same, but I guess that is quite actually the same, but bit shift prevents, because bit shift has lower priority than all these things. Not gonna submit it, it's fine. But then you could also do this number, XOR this number, right? So that's also good. There are a couple of ways you can think about it, but like I said, they're all pretty okay. So I'm not going to explain it that much, just because you can do this with for loop. I think you just have it's just practice. I don't have much to say about this one, so I'm going to just say what I'm going to say for the weekly problem. Thanks for watching. One more thing though is, what is the complexity of this, right? The complexity of this is going to be linear time, linear space, keeping in mind that linear is in the size of the input, and the size of the input is going to be the number of bits, right? The number of bits that represents the number, so that's the number of bits. Of course, there are some caveats. If you really want to be precise about constant with integers and stuff like that, that's fine. You could keep saying, but if you have a variable length integer or like a big int or something like this, then this is going to be the size of the input is the number of bits, which in this case it is going to be linear time, right? Because the shift is linear time, -1 is linear time, and then the XOR is linear time in the number of bits. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. I hope you take it easy today. Stay good, stay healthy, take good mental health. Yeah, have a great rest of the week, everybody. I'll see y'all later and take care. Bye-bye.